In this session, we will see the addition theorems and theorems on a total probability. So, in probability chapter, in 15.7, you have addition theorems. So, what addition theorems defines that for any two mutually exclusive events. So, we should have two mutually exclusive events. We can say it as A and B. Let's say an A and B. So we should know what exactly exclusive event it is. So exclusive events are the events that are having the possibility as that will not have a common possibilities. For an example, I am going to toss a coin and I am going to roll a dice. So possibilities for this event are head and tail. The possibilities for this event are 1, 2, 3, 4, 5, 6, right? So if I take this event as A and if I take this event as B, there is no such thing like common for these two events. So these two events will be called as an exclusive events. Okay, this is how we will define the exclusive events. For addition theorem, we should have two mutually exclusive events, and for any two mutually exclusive events A and B, the probability that either A or B occurs is given by sum of individual probabilities of A and B. So this is how we will write the addition theorem. We can write it as P of A union B, which will be equal to P of A plus P of B, and this is the addition theorem formula. So when we will use addition theorem, only A and B, or sometimes we will have three mutually exclusive events A, B and C, are mutually exclusive. When we have two mutual or three mutually exclusive events, we can use the addition formula. For an example 15.9 in your textbook, the question is, a number is selected from the first 25 natural numbers. When we are solving the probability questions, first we should know what is the sample space for that question. So what is the sample space for this question? Let me write the question first. A number is selected from the first 25 natural numbers. What is the probability that it would be divisible by 4 or 7? This is what our question is. So for this question, if you want to find the probability now, first we should know the what the sample space for the question is. So our sample space for the question is I'm going to select a number from the first 25 natural number. So first 25 natural number is 1 2 3 4 5 etc. up to 25, right? So what's the number of elements in the sample space? Now 25 numbers will be there, and if you kindly watch the question, you can infer that we have to find the probability for that would be divisible by 4 or 7. So here there is a 2 event, right? So I want to find the probability for it would be divisible by 4 or probability that it would be divisible by 7, right? So here I am having two events, A and B. So I am taking A as an event for the numbers that are divisible by 4. Similarly, I am taking the B as an event for the numbers that are divisible by 7. Okay. For the A event, what are the possible numbers that are divisible by 4 in this particular sample space? 4, 8, 12, 16, 20, 24. That's all, right? These are all the possible numbers. We have 28 also, but it is not in the R sample space. We will not write 28 in the A set. So I will stop here. Like we will have 4, 8, 12, 16, 20, 24 as an A set. What's the number of A? Number of elements in that set A na? 6 numbers. What's the probability of that event? 6 by the whole. That n of A by n of S. 6 by whole 25. So similarly, if you find the numbers that will be in the set B na, what we will say, it should be divisible by 7. So 7, 14, 21 and 28, no, 28 will not be there since our sample space ends with 25. So we will have 3 elements in set B, and possibilities or probabilities for this event is 3 by 25. So since we want to find the probability that would be divisible by 4 or B, from our assumption A or B, if I have to find the probability for A or B, this will comes under A union B, this will comes under addition theorem, right? So for the addition theorem, that A and B will not have a common thing, right? So here 4, 8, 12, 16, 20, 24, any of this number, it's not being in this set. Since we can conclude that A and B are mutually exclusive events, since there is no common number between these two sets. So I am having two events A and B, that is mutually exclusive events, and I want to find the probability for combining these two events, so that I am going to use addition theorem. What the addition theorem is? P of A union B, which is equal to P of A plus P of B. So simply substituting the values, I will get 9 by 25. That's all. So this is how we will solve the problem. So before applying the addition theorem, you should confirm that whether your events are mutually exclusive. This will be the very important thing before applying the addition theorem. And you have to confirm also that you have to find the probability for two events as a one thing. So I have to find the probability as A or B, so that I can use the addition theorem. So similarly, we have another question, like 15.11. So in 15.11, a number is selected at random from the first 100 natural numbers. So our S will be 1, 2, 3, etc. 1000, actually not 100, from the first 1000 numbers. What's the probability that it would be multiple of 5 or 9? So I want to find the probability for multiple of 5 or 9. So this is what our question is. So for this question, from the S I can write n of S, and also here also I am having two events, and I want to confirm that whether this A and B are mutually exclusive. If these events are mutually exclusive, we can apply the addition theorem, or we will have another formula. So first I am going to collect the numbers that are multiple of 5 from the sample space. So what will be the numbers? 5, 10, 15, and it will goes up to 1000, right? 1000 also is a multiple of 5. So 1000 will be there in the set A. So how many numbers will be in the set? 200 into 5 is 1000, right? So surely there will be 200 numbers in this set. Similarly, multiple of 9, 9, 18, 27, it goes 90 and 180, etc. 180. Similarly, it will goes 900, 990, 999 varikum it will goes. So if the 999 is the last number na, definitely I'll have 111 numbers in this set, since 111 into 9 is 999. So probability for this event is 200 by the whole set, 1000. Similarly, probability for this event is 111 divided by 1000. So if these two events are mutually exclusive, we can use the addition theorem. But here while collecting the numbers that are multiple of 5, I will get 90, right? So since 90 is divisible by 5, I will get where it is 50, 18 into 5 is 90. Similarly, I am also getting 90 in the B set also. So since these two events having the common numbers, or they have the common things, we cannot apply the addition theorem. Okay va? So what we will have another formula like P of A and B, which is equal to P of A plus P of B. In addition, we will have minus P of A intersection B. So if we can't apply the addition theorem now, we will have this formula, and in this formula we will have A intersection B, probability of A intersection B. So now I have to find A intersection B set, then only I can find the probability of A intersection B. Amava? So I want to find the common things for both these sets. In this we will have like from where we will have the common things. 9, 18, 27, 36 will not be divided by 5, and 45 will be divided by 5, and similarly 54, 63, 72, 81, 90 will be divisible by 5, and also 15 times 9, 135 will be divided by 5, and 180 divided by 5. If we continue these things now, I will get 2 numbers for every 10 times. So here I will have 10, 111. So for sure I will get 22 times. So number of A intersection B will be 22. Our probability will be 22 by the whole thing, and if I substitute this value and this, in this formula, we will get an answer. So to find A union B, what we will have, go 200 plus 1111 minus 22. So 311 22 subtract பண்ணோம்னா 982 289 divided by 1000. So this will be 0.289. Approximately we can write it as 0.29 also. So this is how we will find the answer. To find this type of question, you can use the OR keyword. So if you found any OR keyword in the question, definitely that question, to solve that question, we will use this formula. Either this formula, or if A and B are mutually exclusive, we will use this formula. So anyhow, we will use P of A union formula. So this is what you should remember for this topic. If your probability question has OR keyword, definitely you will use either these two formulas. You should remember. Similarly, we have an example 15.12. In that question, the probability that an accountant's job applicant has a BCom degree is 0.85. Accountant's job applicant who is applied for the accountant jobs having BCom degree is 0.85, and also that he is a CA is 0.30. For possibilities or probability for the person who is having a degree for CA or who is having degree CA is 0.30, and that is both BCom and CA is 0.25. Like the applicant can have both 2 degrees also, right? So for that the probability is 0.25 out of 500 applicants. So total number of applicants is 500. So we want to find how many would be BCom or CA. So here the keyword is OR. We want to find the probability that how many would be BCom or CA. And also note that they don't want the probability for BCom and CA. They have asked like how many would be. So I want to find number of BCom or CA. This is what we have to find. So before finding this, I should find this, then only we can find the number of BCom or CA. So from the keyword R itself, we can say that we will definitely use this formula or addition theorem if A and B are mutually exclusive events, right? So since they have given also the probability like for being both or having both a degree, so we cannot apply the addition theorem. So we will use this formula. I am going to use the event B for BCom, and I am going to use this event C for CA. So having BCom degree is P of B will be 0.85. Similarly, having CA degree is P of C is 0.30, and having both na B intersection C. Note this keyword. If you have seen any of these questions as a both keyword, you should put intersection for or intersection between those two events. So this is also in given. If you have R means you will find A union B. If you have and or both means you will find A intersection B. Note these things. And here having both B com and CA na, for and we will have intersection, so it is 0.25. So I want to find P of B union C. So using that formula, P of B plus B of C minus P of B intersection C. So after simplification we will get 60 and 0.90, right? So P of B union C is 90. So this is not a final answer for this question. As we discussed before, we have to find the how many, not how the probability was. So to find the how many, we can have a formula, right? For P of A B union C, what we will write? N of B union C divided by N of S. Now we have the value for P of B union C, and also we have number of sample space, right? Where it is, since they have given like 500 applicants, that is the total number of applicants, so that would be a number of sample space. So we have the value for sample space and P of B union C, that is 0.90. I have to find the value for this. So substituting these two values to find number of B union C, I will take this 500 to the left hand side, so 450. So number of applicants having BCom or CA is 450. That's all. So this is how we will solve the problem. So first you have to confirm that whether we are going to use P of A union B equal to P of A plus P of B minus P of A intersection B, or addition theorem. If you want to use addition theorem na, there should be no common thing for that event A and B that we will consider. Here we will consider the situations like having BCom degree and CA degree, but in the question itself they have given like the number of persons or possibilities for the person having both the degree. So if they have both the degree as common na, so there is an A intersection B, right? There is a common thing for both events. So here we should conclude like, or we will conclude like, we will not apply addition theorem and we will apply the first formula, and applying those formula I can only find the probability of that event. But in the question they have asked for how many members will have BCom or CA. So to find the number of B union C, I will use that simple formula, right? This is the probability formula. So substituting those values, we can find the answer. So similar to these questions, we have example 15.4, but this will be your homework sum. I'll give you the idea for this question and you can solve this. The above question what we have discussed, in all the questions we have discussed, they have only two events as mutually exclusive, or they will have a mutually common thing. So here the 15.14 problem has three events. The three events also having common things between two and common thing for all three. So for this question we will have another formula like P of A union B union C, which is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. So this is the formula. Using this formula and with the help of 15.12, so this is same as 15.12, but that had A and B as two events. this problem is having A, B, C as 3 events. So that is what the difference between those two sums, but the process is same. Here also you are going to find the number of surveys between those 3 events. So you can take this sum as an homework 15.14. So with this sum we are going to conclude this topic, and we have seen all the cases in this addition theorem part. So if you have any doubts now, you can ask, and also I am going to give some more questions that will come under this topic. So in the set A in the exercise, you are having 27th question as homework. Set A has the questions like theoretical questions, so you can easily solve these questions, easily say the answer for these questions. And 28, you can give me the answer for in the set A. That's all. No, 34th question also you can give the answer. And in the set B, you are having 10th sum as your homework, since that involves an addition theorem. And that's all, I guess. That's all for now. So you will have 4 homework sums. Actually with this 15.14 you will have 15 homework sums. Thank you. If you have any doubts now, you can ask me.